All right. Thank you. Thank you very much for having me. It's a pleasure. I mean, I suffer with all those online meetups and conferences. I really miss the what's missing, what cannot travel through the camera. So I really hope you will invite me again in person next time.
Oh, absolutely. I
But
hate I miss hugs and handshakes.
oh, yep, and good food, good conversations, and frankly, I know that everybody kind of said it today. It's like it's in saying that you miss travel, but I always kind of liked travel, even when it was like a bad word. So now I really miss it. All right, here we go. Um, so yeah, today we're going to talk about best practices in implementing container image promotion pipelines, which is a lot, but we will unpack it and we will be just fine. So first of all, disclaimer: there are a lot of containers those days. Not a lot, but some, and some of them getting traction. And I guess after the latest announcement about end of living the Docker engine inside Kubernetes, they will get even more traction. But for the sake of our conversation, what we're going to talk about today in images are Docker images, even if they are OCI or run in different runtimes and what's not. In the end of the day, Docker images are here to stay. So when I say containers or images or Docker or whatever, it's all interchangeable for the sake of this talk. Now, this is a Venn diagram that I bet some of you can relate. And this is a lot like our industry is like sausage industry. The longer you work in a sausage factory, the less you have the appetite for sausages, and it's also true for Docker, especially when we are talking about trust. I know that by the end of 2020, a lot of us already understand how Docker works, how layers work, what we do with the layers, and how they impact. But in the end of the day, when we have a container running in production, I still have this feeling in the back of my head: is it really running what I intended it to run? And today we'll try to fix that nagging and get rid of it. And as Jason introduced me, my name is Baruch Sadogurski. I'm a chief sticker officer at JFrog. Speaking about in-person meetups, I would probably come with some awesome stickers to give you, but for now we'll have to do with my stickers on Twitter. At jbaruch is on Twitter. Follow me there, and I will use gifs on you as there were stickers. Not the same though. The most important slide of this talk is if you go to jeffrog.com's show notes, you will find a page dedicated to this talk. It has the slides up already. The video, Jason is recording, and I will put the video up soon. He shares them with me. All the links to everything that I'm going to mention, so you don't need kind of take screenshots or photos of the screen or anything like that. And a place to comment, to rate, and a raffle thanking you for being here. It's a nice raffle. I'm not sure if I'm not in error. It will be Amazon Echo Show, which is a very nice device if you don't have one, and definitely nice if you already have a lot, and one more definitely won't hurt. So as you see, we're not a lot of people. That means that you have crazy high chances of winning. Go there and participate. If you happen to forget what's the where all the content is, the link to the show notes is in the bottom of every page, every slide, so you can go there. All right, let's talk about promotion pipelines and how to do or not to do it correctly. When we are deciding how what should be done, we usually start looking for existing pattern and trying to decide, do we need to adapt it? And obviously, when we're talking about promotion pipelines, we do it for years. I mean, CI is what, 95? That's like a lot of mileage. And continuous delivery is also not a new idea. The way it works, and I really hope I don't tell anything new to you in the following slide, is that you have a pyramid in which you have builds that promote from the bottom up, The builds are becoming slower and slower. Not the builds, sorry. The tests are becoming slower and slower because they test more and more stuff. But the builds fall through, and in the end of the day, the ones who survive get all the way to the top of the pyramid to production. Another way to look at this promotion is from this perspective, that you have your sources that are very, very early in the life of your promotion, become binaries right at the CI server, and then you start to promote them. The way you promote them, you deploy them on the environment of the of a certain maturity. You test it, and those tests are not necessarily only like QA tests, but also non-functional requirements such as performance and security checks and what's not. And if a certain build that was deployed on a certain environment um, satisfies those quality requirements, then we promote them through quality gates to the next environment. And promoting them through the next environments means we actually promote them in your somewhere where you have your artifacts, and then from there you deploy them to the new environment of the new maturity. Again, I hope this is kind of the what we already know, all of us. I mean, I will be happy if someone learned something new, but I wouldn't be surprised if not. Now the question is, okay, now what's going on with Docker? And here we have a very interesting answer. Docker makes it very easy to do the wrong thing, and very hard to do the right thing. Doing wrong thing is easy because Docker build. Docker build is awesome format. It's very simple. It's very powerful. You can do everything with it, and it's also very, very fast. So instead of start dealing with all this crap of promoting binaries, you would say, well, I will just Docker build all the things. What can be easier than just retag my Docker file with different with the tags corresponding to the different maturity? I can tag it as in Git. I can tag it as development or staging or production, and then I will just build it based on the tag, I will deploy it on the right environment every time. So instead of promoting the artifact, I will promote Docker file, rebuilding it every time. And that sounds like a great idea, but it's actually not. And to demonstrate why it's such a horrible idea, I thought about creating a very unstable Docker file that I will kind of, wrap in all kind of disclaimers on how no one does that and you shouldn't do that as well. And then I just went to Google, and it turns out I don't need to write an incredibly unstable Docker file because the internet is full of them and people actually use it. This is example, and you can go to, just a reminder, Jeffrey Holmes' show notes. You will find a link to GitHub with this file, and it has tons of clones and forks, and people use it, and it's like super popular. The problem with this Docker file is that every line in this Docker file is a link to a latest version of a dependency. Now, what it actually means that when you rebuild it, when you run Docker build 2 times in a row, you have a very high chance of getting a wrong image created. Not a different image created. It's not that they're wrong. And this is where kind of you can go and say, well, no one does that. We can fix it. We should fix it. Let's fix it. You can say, let's nail down the version of the base image. Let's do that. Is it better? Well, yes, it is. But it become a little bit less unstable, a little bit more stable. But you need to remember that Docker images are mutable. 1904 that we have now is quite different from 1904 that was released in April last year. It's obviously for very good reasons, because security patches and what's not. But in the end of the day, doing that still not guarantees a repeatable build. What can we do? We can use fingerprinting. We can use SHA-2. Now, this is reliable. In the end of the day, it's just a checksum, and checksums always correspond to a certain array of bytes. It will always be the same image. The problem is, what image is this? Which version of Ubuntu am I using? Anyone has any idea? You know what? Maybe it's my cat that walks on my keyboard, and this is the string that it generated with its. It's not even a SHA-2. We have no idea. But you know what? How about those? Jason started with the question of what was your favorite Linux distribution, assuming that everybody have one. So I would assume that's a bunch of hardcore Linux users, some of you probably on Debian variants. Do you know if we can nail down the versions of those dependencies so we will guarantee 100% a reproducible build? What do you say? Jason, what do you say?
You would have to control every one of those dependencies, and if you really wanted to guarantee it, you'd have to actually build it from scratch.
Right. All right. Okay, and that was the easy question. How about this? Can you guarantee now that every time you run this image, you will have the same Java artifact built out of this Maven build? If you don't know Maven, you can say, I have no idea. If you know Maven, you can say, yes, I know how to control my dependencies. But if you know Maven really well, you will say, I have no idea. So yeah, so you know what? How about this? Right, the thing with Docker build, that what it does in an essence is downloading shit from all kind of sources and pack it together. Now, every time it downloads shit from all kind of sources, this shit might be slightly different, and this is how you end up with this. Every time you build, you might end up with a slightly different container, and you end up in production not with what you expected. And for me, I would say this is exactly the reason why we don't trust Docker to the level that we want. Now, what we should do is the right way, and we spoke about it. The right way is actually doing it with mutable and stable binaries. What we want to do is something like that. We want to build it once and then promote it through quality gates from development to staging to production in those three examples. And I keep talking about those gates, and you might say, like, what's up with those gates? Well, they are crazy important. They're crazy important because those gates won't waste our time in testing what shouldn't be tested, but more importantly, won't allow untested or not staged binaries go into production. So now when we realize what's wrong with the simple solution, let's go with the right solution. And let's build a rock solid pipeline. And the idea is, how do we separate dev from prod? How do we build those gates and make them as strong as possible? So we have a lot of options with Docker. And option number one are labels, Docker labels. And Docker labels are metadata tags. They are key value string pairs that you can attach to anything, including to an image. And then it's fine. You declare image, let's call it maturity dev. And then when you deploy it, you need to check on your deployment that the maturity is really set to dev, and you're good, right? Well, in theory, but what happens if you called your tag a maturity, but your submission hook checks for a tag stability? Or what if you made a mistake, like a string mistake? Everything will work, and it will work just fine. It's just you will have in production images that you didn't really want them to be. Now you can say, well, there are better ways. How about Docker repositories? Docker repositories are areas in the Docker registry which are completely RBAC controlled, right? You have your username that you decide if you want to allow them or not. And this is great as long as you can set up your Kubernetes cluster to fetch from one repository and you're done. Well, not really. The concept of repositories in Docker come from repositories in Git or in GitHub, if you wish. And repositories in GitHub are not designed to be maturity repositories. They are project repositories. You have a project, you have a repository per project in GitHub, but since you don't promote sources through a promotion pipeline, but instead you promote binaries, you don't have the notion of maturity in GitHub at all. You don't have repositories for dev, staging, and production. And this means you don't have them in Docker registry as well. What you really want as the strongest quality gates that you can get is having registry per environment. So you will have here you will have a dev registry and then a system testing registry and then a staging registry and then a production registry. Now, this is great because then your clusters will only communicate with the registries they're supposed to see, and you won't have any problems with visibility. This is like the perfect solution. The problem is Docker will say, not so fast. Not so fast because they are pretty strange limitations inside Docker when it comes to what we can do with registries. And this comes from the standard that, again, getting rid of Docker in Kubernetes won't help. Those standards stay with us, and those are the standards of Docker Hub, Docker tag. Docker tag allows you to specify a host, a port, a username, and the name of the image. There is no way to express which registry inside this host do you want to get your images from. This cannot be supported when you do Docker tag, Docker push, or Docker pull. There is no way to express it. Someone back in the day decided that one registry per host should be fine for everybody. So this is, we cannot kind of decide that we give up, or we can look for solutions. And we have a couple. The first solution is virtual hosts or virtual ports. So we can rewrite the request when it comes to a certain host or to a certain port to actually go to another host or another port that we will have the registry token in it. So basically, here's an example in Nginx. And today you'll probably won't do it with Nginx. You might want to do it with your service mesh, and that's fine, whatever works. But the idea is that when you have a request to a physical port 5001, you are going to rewrite it to a virtual port, which is like what, 80, but it will go to the Docker dev URL and not the root. And you will do the same for 5002 for staging and maybe 5000 for production, as it is a beautiful port. Now, this is nice, but it adds complexity. You need to manage another tool. You need to manage those writing rules, rewriting rules, and it's basically a hassle. Instead, we can abuse stuff. So this username token that we have in this URL is only used in regards to Docker Hub. Apparently, whoever thought that it's one registry per host will be enough for everyone also thought that everybody are going to use Docker Hub forever. So they kind of embedded a completely not private, but I would say limited use case of having usernames as a part of the path in the path itself. But if we don't use usernames, but instead we need a token for registry, we can abuse it and use the username as a token to which registry our request is going to go. So, and this works, right? You can definitely have now more than one registry on one host, and you will specify which registry you go to by using this username that no one uses. This is nice. The next question is, how do we promote? Because when we have registries in different hosts, paying a network price for moving artifacts between registries is natural. They are on different hosts anyway. So I don't have a problem with pulling, retagging, and pushing because they are going to different places anyway. But now, when we have multiple registries under the same host, downloading it, retagging, and pushing it back to exactly the same place is just insane. So there are tools that give you everything that we spoke about without the need of pulling, retagging, and pushing. And those tools, there are a number of them. I will obviously talk about the JFrog technology because this is who sponsored my flight to Philly. Ha ha ha, not funny. I'm going to cry now, but okay. So yeah, JFrog Container Registry and JFrog Platform and JFrog Artifactory, all of those support exactly what we spoke about. You can see here on the left those registries which are a part of the same tool, sit in the same kind of application and work transparently behind the scenes. Docker dev local, testing staging, Docker pro local, all those. And then you can see how the promotion here that will be triggered by whoever orchestrates your pipeline, and I use Tecton here, but it can be whatever, including JFrog pipelines, by the way, then it will trigger this promotion from one repository, from one registry to another, just by an API call. And because it uses that duplicated storage, nothing will actually happen at all. It will just, the visibility will change. And then when we will get to where those images can be fetched from, they will be displayed or available through the right registry. But in the end of the day, you just sit in this one tool. There are a couple of interesting parts to see in this diagram. First of all, the Docker Hub Remote. This is a proxying registry for any Docker remote registry. In the most popular example that will be created out of the box, obviously, is a Docker Hub. Now, considering the latest developments on the Docker Hub front, this becomes a very, very important feature. You probably heard how Docker will start or already started rate limiting you per number of requests that you can issue to Docker Hub. And obviously, if you have a pretty robust CI infrastructure, you will run out of the free request very, very fast. Now, if you have this proxying registry, then obviously you will be protected from bombarding Docker Hub with requests and getting yourself limited, because after the first request, now you have your image right here cached, and whatever you need will come from here instead from directly from Docker Hub. And again, this, as opposite to paying to Docker Hub, this doesn't cost you anything. And the last one, the Docker Virtual, that's a virtual registry that does two things. First, it provides visibility to whatever set of registries you want to see. And let's say we have a developer here and they definitely have back problems from sitting this way all day, but they obviously need access to everything. And this is how we provide them with Docker Virtual and say everything is exposed. You see all the images that are proxied from Docker Hub. You see all the images here, regardless of their maturity, and everything is fine. But when you are going to deploy from your machine, or we don't deploy from our machine, so our CI server will deploy whatever we build first, it will be deployed to virtual, but end up in the Docker dev local in the beginning of our promotion pipeline. And then we have the orchestrator that will do the checks, promote, do the checks, promote, do the checks, promote. And the checks are, as I mentioned, different environments. Now, those environments can only see the registry they know the existence of, right? So the production cluster only knows about Docker prod local registry. It doesn't know about anything else. So it won't make a mistake of having a not tested image out there. And again, the promotion is fast, free, no problem at all. We don't need to rebuild from scratch any time, every time. So in the end of the day, we have this win-win-win, that you have a single point of access to multiple registries when needed. You have a completely unrelated environments that don't know about each other, and you have immediate and free promotions thanks to deduplication and common storage for all those registries. So this is great. And when we spoke about Docker remote proxy, I kind of allured on this is how you keep your base images from being deleted from Docker Hub whenever they start to delete images that are not in use. So you understand how important it is to keep an eye on your dependencies and keeping them in your cache in order to have a reproducible build anytime in the, any moment in time in the future. But Docker-based images are not our only dependencies. And this is, again, the same tool that we spoke about, the JFrog Container Registry or whatever other tool that you pick, need to be able to cache the other dependencies as well. So this is the Docker images in the Docker remote cache. And here are other dependencies in what we call in our terminology, the generic repository. So you see here, we cache the JDK and we cache the web server, and we also cached the application file as well. Now, not only you can get all this from the free Docker Container Registry, but you can also get the JFrog free tier that is actually the entire JFrog platform for free for you to use. And there are, so it's 26 different repository types that know how to treat those images natively. It's not that the files are out there and you can always get them, but your build tool, you run npm install, you run mvn install, you run whatever it is, will know how to get those dependencies, again, from remote repositories, cache them in your tool so you will have a reproducible build, and then serve them to your package manager, dependency manager build tool. And this is how you keep an eye on all of them, actually. So it's very important that you own your dependencies in whatever tool and whatever technique makes sense. But in the end of the day, the principles are those which are important. You need to keep an eye on your base image, your infrastructure, and your application files. So all of them are important. Now, you remember how I complained how horrible it is that this is the latest version, and I kind of badged it and said, well, this is bad. Well, first of all, it's convenient, right? We have this notion of nightly builds, nightly dependencies, snapshots, patches, call them whenever you are, which are very convenient, that are updated automatically, right? It's convenient for our dependencies, for our development process, inter-team dependencies, and also we need to remember the security patches that we want to end up in our dependencies anyway. The real question is, when do we want the static versioning, immutable version, and when do we want this dynamic nature of dependencies being updated themselves? And we have a trade-off: static, assigned ones, remind and changed, reproducible builds, latest good state image, easy to use, but then what version is it really? And how it is reproducible? The answer for this trade-off is don't compromise, have them both. Double tagging is what actually helps. So yes, Docker image can only have one tag. You cannot say it's version 8, but also latest without duplicating the tag. But again, remember, we're talking about the duplicated storage. And then why do you even care? Here's an example in which you have a build, a latest Docker image, and we know that it also the same as the image version 26. How do we do that? How do we assign this metadata? Very easy. We do it through REST API during the build. when we build the latest image number 26, we give it a static tag, and then we say, but also tag it as latest, and also make sure that you mention that it refers to number 26. It's all in REST API, or in our case, in JFrog CLI, or in case of specific CI servers like obviously JFrog CLI, but also Jenkins and others, we have this functionality built in our plugins. So it's basically, you can get that in many ways, and you can either use our metadata, like in this example, this is property that you set again through Artifactory, but also remember we spoke about those labels. It will use exactly the same. So you can see here a mix of metadata that you work with in JFrog platform and of Docker labels as well. It's all get mixed there, and then it's all available for your query using JFrog query language. You can ask any questions about any metadata and mix and match different types in it. So this is how you have double tagging, and you actually save. It's a win-win. You basically win from both worlds. So just to summarize what we spoke about: build only once, separate environments, promote static binaries that you have built, and own your dependencies, so you will have reproducible builds and you won't be on mercy of whatever they decided to do with the remote registry that you download your artifacts from. So with that, I'm at Jabaruch on Twitter. This is CubePhilly. I don't know if it's a real hashtag. I hope it is. Sorry. Jeffrey Lomsa show notes. This is where the slides, the video, soon all the links and the raffle are. So go there. And this is all. Now, I guess we have time for questions, if there are any, or we can go with Adam.
Yeah, I just a quick question before we move on.
Here we go. Adam asked the question. That's
yeah, it's just it's really interesting, honestly. And yeah, I wanted to know, like, especially for like caching your artifacts, how long do you guys have like a data retention? How long it takes for?
Yes. So we have, first of all, there are different types of registries. There is a local registry in which you deploy your own artifacts. And there is the proxying registry, which is kind of a proxy for the remote. And it's usually considered like more or less, how do you say it, less permanent, if you wish, right? So first of all, there are different retention policies that you can declare on different types. You can say, well, I expect my caches to be out there in the internet, so I'm not like super attached to them. But my own artifacts that I build, this is kind of my product. I need to make sure that I never delete them. And even there, you can decide, well, I know about my pipelines. I know that the artifacts that died on QA environment, I probably don't need them around. It's just bad builds. On the other side, those who ended up in production, I want to retain forever, for 7 years, for whatever. Now, for the remote proxies, you can say, well, I saw some shit coming on Docker Hub. I don't trust them to be around forever. So I need to start treating my caches very seriously, because I might not be able to find those images anywhere. And then you can harden your requirements on retention on remote proxies, or just move those artifacts. And you remember that move is free. It's just they will appear in another place. Move them to your local registry and say, okay, here I feel that they're here forever. Even if someone will see the name cache in the name of the registry and will decide to purge caches by killing everything inside, I still will have my artifacts because I promoted them to local from being ephemeral caches.
That sounds really good. Another question I just have too is that, are you guys focused only on Docker images, or is all like probably all the OCI?
I have this nice screenshot of 26. Yep. 26 types of images, and the principles apply to any of them, right?
Okay.
So if you want to build a pipeline of Debian packages, it will be exactly the same. The promotion works the same. You can create the same set of Debian repositories and then promote through them. You have a support for virtual Debian repositories that can proxy your PDAs or whatever you feel like. And obviously the local and the virtual, everything works. And
is that,
yeah.
sorry,
Now go ahead.
is that extendable? So can I add my own type?
It's extendable by us, and
Okay.
we traditionally were the leaders in the number of artifacts that we support. You might see here some very, I would say, like very significant misses, and I guess the most significant miss here is Rust. The good news are that we've been kicking our product in the head very heavily about that, and Rust is coming. But I got I got a permission to announce where our head of product lives if they don't deliver Rust in Q1 2021. So his head will be on a stick if he misses this deadline. Rust is coming very, very soon. Another one that is coming is Terraform. Also kind of a big deal that is not here, will be here very, very soon.
That's great. With solo products, with Envoy, and now Istio is adopting this too. There's a way to extend this using WASM, WebAssembly. Is it that something that you guys also looking at?
Yeah. So what you need to remember is that the generic repository is kind of
everything.
Bucket, right?
Okay, got it.
So you can have any types of artifacts in a generic repository. It will work again exactly the same way. The only thing that you won't have is if your tool have a custom indexing, we don't know how to index it and generate metadata. For example, like for Debian, right? So you need to calculate the metadata and to assign artifacts and all that. And it won't happen just because you put your files out there. You actually need a knowledge of the algorithm. The tool needs to know the algorithm, right? So this is one thing. And the other is this custom layout. And this is a Docker great example. You cannot just throw a bunch of layers into a storage and expect Docker pool to work. Instead, there is a layout that it needs to look at the manifest and figure out what layers and everything. And again, your tool is supposed to know this algorithm in order to work. This is, by the way, why, and I say it was a relief, most of the Docker registries in the world suck, because no one wants to deal with this knowledge of the algorithm and adapt to every new Docker version. Instead, they take this as an encapsulated piece of software, what it's called the Docker distribution, and embed it. Now, the good news for us is the Docker distribution sucks. This is why if we are not lazy and we go and reverse engineer this logic and can embed it in our product and make it better, this is where we have the competitive advantage, and we still give it for you for free. It's just better.
Yeah, thanks.
So, any other questions for Baruch? All right.
Helpful. Thank you.
All right. Thank you very much. Glad to hear that it's helpful. And I guess, Adam, take it away.
Perfect. Okay. Yeah, I'm really happy to be here, and thanks for the invite. So I basically gonna do a lightweight presentation. It's more oriented into more type of discussion more than actually a hands-on or demo approach or something like that. So yeah, first, yeah, a little bit about myself. Adam Saya. I work at Solo as a field engineer. I have a background in API gateways and service mesh. I've been working with these technologies for a couple of years now. Yeah, feel free to reach me out either on LinkedIn or any Twitter. And I'll be happy to, keep the conversation going. If you have any questions, see if you have an opinion, that would be great. Yeah. So this presentation will be like pretty in intro. It's not something super technical. As I said, it's more like to drive the conversation and have like a chat about it. Yeah. So first, I think everyone here knows what's an API, but just to stress, application programming interface, something that is going like every enterprise is using it somehow to either expose a part of their business, or either it is for actually communicating between different components within the same ecosystem. So an API is something that for us, as an enterprise, you need to have a way to basically manage them, expose them, secure them, and things like that. So this is an introduction to what's actually an API gateway at first place. Let's talk about the north-south traffic. So this is what we always hear when we start talking about API gateways, is that we have this kind of north-south traffic. So anything going from a client, like let's say a mobile phone calling like an external service that your cluster. So this is kind of a north-south traffic. You have a client calling a cluster, an endpoint, something. So entering your structure, entering your clusters. So an API gateway became like a kind of a standard before everyone like talking about the service mesh. It became a standard to basically secure any traffic going inside your cluster. It's a piece of software that sits between the client and your business that actually provides basic stuff like either routing and also more complicated capabilities like aggregating data from different components, like transformations, like rate limiting, and different security processes. So you put your API gateway in front of your cluster, and it will sit between, as I said, the client, can be anything, calling your part of the business, and secure actually this traffic. Now, what's kind of the main API gateway capabilities? I talked about it quickly. So, we have either request processing, so it's going to be routing and things like that. You have security components. You can secure your APIs with different type of technologies. You can have OIDC, basically your jobs. You can have your just basic auth and API keys. Any type of security like that. You can have definitely the tracing going. Tracing all the calls going into your network. And you have also something like like load balancing, and you have traffic shadowing if you want to route the traffic somewhere else, rate limiting, and things like that. Now, so historically, people used to use an API gateway in front of their big monolith, where it's actually was handling the part of the business which is important, that we're exposing your APIs. Now, the shift that happened this couple of past years is that we moved more from a monolith approach, where we used to have a big components having all your logic into your monolith. They all communicate each other, kind of a tightly coupled, because basically everything is all together. And actually, this introduced, that was having a lot of issues, obviously, mainly, for example, upgrading a part of your business. Let's say you just want to upgrade only a part of some components. So you had to actually build everything, and it's kind of a hard deployment process. And it was really complicated for many things. Now, the solution for that is basically to use a different approach, which is microservices, where you'll have this component, instead of have a big picture or have a monolith, you'll have different components here and there, right? So we have 10 services, A, B, C, D, and they all talk to each other through, through the network. So API calls, things like that. Now, with this new approach, that's kind of simplified a lot of things. I can mention just, the example I gave for monolith, the fact that if you want to just, replace a part of your business, you have an old component that handle, probably a legacy code or anything like that. You want to just change that. It's pretty easy to just, because of, the interaction between the components through like APIs or things like that, it's pretty easy to just shift and go build this from scratch or modify something, deploy it, pretty much your application. If you're expecting the same interface, whatever it is, it will just work. It also adds kind of a flexibility in terms of, if you want to scale a part of your business. Let's say you have a monolith, and it's only a part, there's just like some component that is really needed to be highly available, or it needs to scale. Using a monolith approach, you'll have to scale everything, which is not efficient at all. Now, having your microservice, you can just scale a part of your business, and that's all fine, right? But that's introduced a lot of issues also. It's kind of solved a lot of complicated problems, but also introduced some. When you have a monolith, it's kind of attack surface is kind of small. You just have your monolith, and here when you have microservices, definitely a security is a risk. Observability type of like what's going on in my system. Hey, one service is not behaving. I don't know what's going on. I don't know how to trace the callback to exactly what's failing. Stuff like security. Yeah, I talked about it already. There's multiple problems coming that actually start popping up because of actually the microservice approach. So for that, the first approach that the kind of the industry had is that for every microservice, when you create your microservice, you'll have a library that you attach to it, right? So you're writing your code, like your service in Java, for example. You have some libraries that handle security, observability, all kinds of cross-cutting concerns. But this was not really scalable, because actually how you handle them, how you configure them, how you have like a polyglot approach to your infrastructure. Let's say you want to have a team creating, they create a microservice in a different language. You have like a library probably in some, for Java. That creates also kind of really complicated scenarios. So first talking about the traffic going between the services, a service mesh was basically a solution for that, where you'll have a sidecar, you'll have a component which is sitting in the same pod or the same space as your part of your application. And it handles all these cross-cutting concerns, handles all the security, the tracing, the logging, many things that can actually just reuse and are in a polyglot architecture. Doesn't really matter to be actually in the application. So you keep you keep the sidecar just handling mainly all these cross-cutting concerns, and you have your service that is probably just implementing your logic. It's going to also simplifies the fact that developers now are focused on only delivering the business part of your application and not dealing with all this, cross-cutting stuff. And from a service mesh capability, you'll have also request routing. You have security features like JAWS and stuff like that. You'll have the tracing, TLS. You'll have traffic shifting and things like that. So if you guys look at this list, it's mainly the exact same list we talked about when we talked about API gateways. And this is why actually it started introducing like this kind of a complicated approach of like, hey, where is the API gateway fitting now? So we have a service mesh, so yeah, if you look at the traffic that we have right now, you'll have north-south traffic and east-west traffic. East-west traffic is between services, and north-south traffic is basically, as I said, between the clients going to a cluster. People at the beginning were like, hey, you know what? Your north-south traffic is handled by the API gateway, and the east-west traffic is handled with service mesh. That basically was the kind of the standard answer, specifically when we started, like, you know, when the service mesh started emerging, like probably 3-4 years ago. But the reality of this is that now we will have multiple clusters. If you talk about big organizations, they don't have only one cluster. They have different clusters. They all talk to each other. The notion of east-west and north-south don't really matter nowadays. It's only you have like multiple meshes, you have multiple clusters, multiple gateway, multiple services that all need to talk to each other and need all to be managed. So yeah, this is why I actually introduced this confusion. You know, there's an overlap between the API gateways, service mesh, and a lot of features. I listed them before. You will have also an overlap in implementation. If you take an example of, for example, Istio, and like for us, we're using in Solo. I don't know if you guys are familiar with our products. We have a product called Glue, which is an open. It's an API gateway, which is open source. It's also based on the same component, which is Envoy. Envoy is the API gateway that we're using behind the scenes. Envoy is using it. Solo is using it for us, like we're using it in Glue. And also, if you look at Istio, they're using it as to implement their service mesh. And actually, all the component that sits with the service, actually instances of Envoy, right? So there's a big overlap in implementation too. And also, there's this belief that, you know, it's kind of shiny now. Service mesh is going to replace all the API management. It's going to replace all the API gateways. You don't need that. But the thing is, there's a lot of similarities, right? We showed the list. You know, specifically when you go to, you know, traffic control, traffic routing, like going to multiple services, all like security related to TLS and jobs. Network observability at some extent, because obviously when you hit the gateway, it's not like when you see all the mesh, and you have policy enforcement. But there's also a lot of differences when you have some issues that are not actually, some issues are really meant for like only the edge issues. So they're not your mesh issues, it's not between services within your cluster. It is basically between the client calling your cluster that you need to secure traffic in some sort. For example, having YDC, like let's saying, hey, every traffic going to my cluster needs first to actually, you know, log in into my IDP, verify this user before, you know, it populates all this API with the correct JOS. Can be propagated to your service mesh to be validated, but you have, for example, having standard authentication concerns. You'll have, like, for example, a WAF approach. Like, hey, you don't want to allow any traffic going to your cluster. You have like more like an enterprise security where you say, hey, you know what? Any traffic going from these IPs should be denied, or things like that. This doesn't really make sense from when you come to a service-to-service approach. Message transformation. You know, a lot of cluster, obviously, when service talk to each other, they already define some language, or the APIs are already defined and things like that. Now, when you have concern, for example, if you have, let's say you have a gRPC services within your cluster, but at some point you want to expose different type of protocol transformation, basically from your client to your cluster. You can define that at the gateway, where you can have your cluster completely talking to each other through gRPC or whatever, but you have a gateway itself handling that, hey, for this type of client, transform my REST call to you know, gRPC, and you can have like kind of standards to give like more definition of how your client will interact with your system. You can also have specifically, you know, like the API, when you have like APIs within your cluster, you don't want to expose everything. It doesn't make really sense to have all your services exposed. You have some private APIs, public APIs. The way you decouple the APIs between your front end, like the things you expose, are kind of completely abstracted from what's your cluster use. So it's not like a one-one mapping or things like that. It's more like a complete decoupling between something that. So if I want to stress that enough, is that the gateway itself deal more about the application side of your business, where so you have the API gateway that handles the application, like APIs that you want to expose, the routing, how to deal with the client, the different type of clients and things like that. There's more generic approach. Now the service mesh itself is a different level. It's kind of complementary to what actually the API gateway is providing. The service mesh is more into defining like a flat network between multiple clusters, managing service communication, tracing through multiple components, solving these issues that the API gateway won't solve. But for example, like when I was talking about this microservice approach and multiple services, the way to trace your call from the front end, so from your call all the way to your back end, that's what your service mesh will help do. When the call is hitting your endpoint, you can definitely trace it back and see exactly what's failing. With the microservice approach, if you don't have something like that, it'll be really complicated to debug your system. So this is why I'm saying that service mesh, it's a different layer. Okay, we have the API gateways, the service mesh, and basically you have your infrastructure, Kubernetes deployments, your services, and things like that. Yeah, so yeah, this is probably a quick conclusion here. It's like, okay, so what should I adopt? So if you have a API gateway, should I go with service mesh or both? So as we always recommend is that you don't always need a service mesh. It's all depend on your infrastructure. If you don't have a complicated infrastructure, you don't need actually to bring something as heavy as a service mesh within. So you probably want to start with having an API gateway that secure your incoming traffic to your cluster, having your business policies, like your routing, your failover, your security, and things like that. And then now, if you start having like a more complicated architecture with different clusters and things like that, and you want to have a flat network, you have traceability over your cluster. Obviously, you're going to introduce a service mesh to manage this, and they can actually be complementary between the first layer to the second, all the way to your application. So yeah, this is that was mainly what I was going to talk about. I can probably going to show just a small way, like what's an API gateway in the sense what we can do with it. I'm going to use a Glue, which is our API gateway. I'm going to show you how to do, for example, an YDC authentication using it. Okay. So let's say we have. First, if you guys have any questions, I just probably a good time to ask them. Okay.
I have a question. What is the performance impact? I know you are implementing the sidecar, like Envoy proxy is a sidecar. What is the performance implication when we implement service mesh?
Oh, well, there is. It's completely, like if you take Istio, the whole mention is completely negligible.
Okay.
So there is obviously there's some more steps within your traffic. You're not hitting your backend directly. It's going from sidecar to sidecar first. Now, the amount of latency it has compared to what all the benefits you'll have is completely, it's
okay.
That's how it is.
We've been experimenting quite a bit with Istio at one of the projects I've been working recently, and in if you're throwing an API gateway in front of a monolith, you're going to notice a little bit of a change because the monolith is used to having direct communication, everything very fast. With a really distributed, hyper broken up microservices architecture, adding that little bit of latency is barely noticeable.
Okay. Thank you.
All right. Yeah. So let's play with this with the gateway to show things that we can do. For example, with the gateway that we can't do with Istio. For example, if you take this, if you want to implement, for example, YDC at your gateway. So here it's with Glue is an open source project. It's mainly if coming from like an Istio, if you deal with your virtual services, you kind of know exactly it kind of looks similar the way you handle your route your traffic. So here I have a virtual service, basically just a CRD. I'm going to persist in my Kubernetes to route some traffic to just an HTTP bin. For that, I have I'm gonna. Oops. Yeah, I have my virtual service created. So basically, I'm gonna be able to route traffic to my gateway. Let's make a call. Oops. Okay, so this is because I'm already logged in. But if you, no, actually, yeah, I haven't activated the OIDC yet. If I look at my configuration, I have just a routing configuration to my service. Now let's say we want to add OIDC to it. Right. Haven't been persisted. Yes, I haven't changed it. So actually, I deleted the code instead of incrementing it. Error. Okay. What did I do here? I have my options. There you go. Okay, now if I look at my service, probably go through incognito because yeah, see here that I have to basically log in before going to my backend. But this is just a quick example of kind of policies that are more applicable to a gateway compared to a service mesh. Obviously, you can keep this traffic going with your, now that you have your jobs, you can do validation as your sidecars for these jobs. You can do more like a kind of a tracing all the way going to your, it's kind of complementary. This call can go all the way, from service to service, and you can trace it from the gateway where you applied, you're logged in, you have your job, and then, going all the way, as I said, from service to service. Sorry, that's mainly what I have. That was a quick introduction. That's mostly I wanted to know if you guys have any questions. That's probably more like a discussion kind of type of presentation.
So other question is like the logs you mentioned in the service mesh, can they be sent to like a EFK kind of a stack, Elasticsearch, Kibana and FluentD kind of environment? Because when we have service mesh, again, there will be a lot of logs because each pod will have envoy proxy. So is it
Right.
something that can be pushed to Elasticsearch and from Kibana? Can we take a look at it, or how does it work?
Yeah, it can definitely. It's kind of seamless integration with kind of this kind of services. You can have so yeah, you can, if it's not. So there's different approaches. There's one where you can have like like a kind of looking at, for example, Datadog. You'll have your agents running on the cluster, collecting all the data, all the logs, and persisting them, and you can just basically look at them, trace which services is doing them, and stuff like that. So you can definitely do that.
Okay.
How are you guys using Istio, for example, Service Mesh and stuff like that?
Yeah, so we are actually implementing OpenShift right now.
Mm-hmm.
So in OpenShift, we've started using Istio. We're not in production yet. We're just in the UAT, dev and UAT. So we're still experimenting. Trying to implement EFK soon. So I just wanted to, trying to figure out if, how can we use EFK with service mesh. So we're still trying to figure out things, but yeah, we're starting to implement it.
Yeah, definitely. Yeah, service mesh is sometimes kind of complicated. First, the first steps when you try to implement it, it's kind of complicated compared to something else. But
yeah, a few things I found out, like it's very not friendly, I guess, with the namespace. Like you create one virtual space in one namespace, and I saw that the URL was kind of getting not working properly. If you have the same namespace, different namespace, same URL, so we had to change the URL. So things like that. Right.
And you guys have like multiple clusters, or will be like just?
We have one cluster for dev UAT, and then 2 stage clusters and 2 production clusters. So that's the plan right now. But in dev and UAT, it's one cluster, but then the URLs are same. For dev, it's one for UAT. So we had issues there, so we had to kind of rewrite the virtual service so that we put /dev for dev and /UAT for UAT. So we had to do some things like that.
Yeah, I'll definitely obviously recommend like a tool we have. It's open source called GlueMesh.
Okay.
It's basically kind of an abstraction. It's kind of a control, a management plane on top of your control planes. So it actually allows you to definitely create a simplified policies. I know that sometimes especially if you're using Istio, it's going to get complicated to do things like, for example, failover to different clusters and things like that. And with GlueMesh, you'll be able to, route traffic easily using like a simplified CRD. I think that's a good, good topic for a next meetup.
Separate presentation. Okay. Yeah.
I was just thinking about some of the things I've been dealing with Istio and with just network traffic in general. I'm not sure if you have seen this recently, but it looks like the I'm blanking on the name. They're nothing. Pod security policies. The pod security policy API. It looks like it's being deprecated, or in the near future. I was curious what how you see the policy enforcement, things like that, and then being part of the API gateways and meshes moving forward. Because while the pod security policy is very, very much focused on the thing running on the machine, I'm curious that what is your take on policy, network policy, machine policy, as with the different suite of tools that you're working with.
Yeah, so definitely for us, especially if you look at like a sidecar, if you look at like an envoy, for example, the capabilities you have there regarding network is kind of powerful. I mean, it's not completely it's not the same level as something where you hit like Kubernetes APIs. Obviously, it's a different thing. It's a different level. Now, for your main use cases, I think the sidecar approach is kind of flexible enough to deal with a lot of all your airbag, all your traffic shifting, traffic security, and things like that.
Okay. Any other questions for Adam? All right. Then let's just move on to closing business. Now, I didn't do this when we opened because we only have a few people here, but anybody looking for a role, have a role that you need advertised here in the CNCF space at all? I do. I used to do it open, but I forgot to do it at open. Cats always love the Zoom calls.
Yeah, they do.
All right. So with that, I will give you a sneak peek of what's happening at our next meetup. Let me just share my screen real quick. So that's December. So I was hoping to have the January meetup up, but you all get to see a sneak preview of it because I haven't gotten confirmation from the second speaker yet, who I believe will still be joining us. It's just I don't usually publish until I have a for sure. But January's meetup right now will be January 11th. We'll do another 6 to 8. Michael Forrester will be talking about working with logs, and then we have, oh, where's my draft? I lost one. I have another presentation. So another one is Kubernetes. So it's taking it's an interesting conceptual talk. I will have it up later this week. I'm waiting for the final okay from the speaker to get it up. But he said that yes, he is interested. He sent me everything that I need except for the final okay to post it. So just know that'll be January 11th, 6 to 8. That again will be an online meetup because COVID and all of that. But yes, so Adam, thank you for joining us tonight. I'll send Baruch an email to thank him for his time as well. Anything that you want follow up wise, shoot me an email. I'll make sure it gets into the post email. And before we close tonight, any questions, comments, needs from the community? All right.
Thank you guys for having me here.
Thanks a lot.
So thank you all. And we'll see you all in January. Have a great holidays and a happy New Year.
Awesome.
Thank you. Same to you.
It's on, please.
Good night all.
Bye-bye.